Okay, so on polyatomic ions, or on page 9 of your notes, the second paragraph, let's talk about polyatomic. So we talked about it a little bit, poly being many, so many atoms in the form of an ion. Or I think there's a definition also here. Ions that are made up of several non-metallic atoms joined together. So we have a compound with a charge. So we can also have compounds that have charges as well, that have an ionic charge, that don't have a full energy level, and they also want to gain or lose to become full. So the nice thing is, on your periodic table, it actually shows you a chart with the polyatomic on top, and it's even titled polyatomic ions. So if I ask you in a test, give me an example of a polyatomic ion, you could just write down any of them on the chart. Okay, so suffixes are all ate and ite. There is an actual way you learn in Chem 20 to actually figure out the ate and the ite yourself. For now, you just can look on your periodic table, and if you match the symbol to the name, it'll tell you if it's ate or ite. Okay? And use to differentiate between pairs of similar ions, but do not tell you how many atoms are in each. The ate and ite, there's a special way to kind of help figure out. We don't have to worry about this really until Chem 20. Okay, all we got to do is be able to name our ionic compounds that are polyatomic. To name and write formulas for compounds with a polyatomic ion, look at the formula, name the cation, then the anion. So the naming is really the same. Naming is pretty easy. It's a little bit more work given the name to make the actual chemical formula. Oops. To write formulas, follow the same rules, but in polyatomic, we need brackets. The reason why is, say if I have PO3, which has a negative charge, just making up a polyatomic. If I need two PO3s, I would write that, the brackets and the 2 on the outside, just indicate I need 2 whole PO3s. Okay, it's very important. We have to use brackets when we want more than one polyatomic ion. Okay? And the subscript outside of the brackets applies to all the elements inside. So in that example, let me use nitrate. So if I had 2 nitrates, what this means is, how many nitrogens total would I have? How many nitrogens would that mean? If I have 2 nitrates, 2 of these NO3s. 2 NO3s would produce how many nitrogens? Anyone? 2. Give me 2. That means I have 2 nitrogens. And how many oxygens would be in 2 nitrites? So I have 2 nitrites. 1, 2. How many oxygens would be in it? 6 total. We multiply these. 3 times 2 would be 6. Okay? So we literally are bonding 2 nitrates. The compound itself has an ionic charge. Okay, so let's look at some examples, because I think that's the end here. And so what page is Line Master 10? 15? 50? 52. Page 52. And again, you will need your periodic tables handy, so have them available pretty much every day, right? It's a staple. It's like having a hammer if you're a carpenter. That's the word. Sodium and sulfate. All right. So we first look up sodium. We want to bond these together. And we look up its charge. What atomic number is sodium tessa? 11. Okay. So 11, and so its charge is Na+. Sulfate. Elsie, sulfate Now, this 8 right here, it's not an I, tells you to look on your polyatomic table. Okay? So if it does not end in I, we need to look at the polyatomic. So that's that chart above. So now, Elsie, can you tell me what sulfate is? SO4, 2 negative. So our SO4 molecule, or compound, has a 2 minus charge. So we're going to treat this the same way. We're still going to do our switch. So we need, for every sulfate, how many sodiums do we need? 2. And how many sulfates do we need? 1. Now, because we only need 1 sulfate, so 2 sodiums, only 1 sulfate, so we don't need brackets. Only when we need more than 1 polyatomic do we need brackets. And in all ionic compounds, what's the state? As long as we have metal and a nonmetal, it's a solid. Okay? And so its name would be sodium sulfate. Sulfate, just so you know, so if you see it both ways, can be spelled with a PH or a T, or just an F, sorry. PH or an F. Either would be fine. So if you see a PH, it's really still sulfate. Okay? Lead 4. So Eric, lead 4, can you look up lead 4 and tell me what, oh, well, you don't actually have to look it up. What symbol is lead? Do you remember? PB, peanut butter, I like that. And we know the charge because of the Roman numeral. So what charge are we dealing with? Yeah, exactly. So what Roman numeral is this? 4. 4 plus. Okay. And Aaron. Oh, did we already do sulfate? That's boring. That's okay. So let's grab sulfate again. Now, we still reduce before we do our switch. So lead will become 2. And then how many sulfates do we need? Or what, the charge, basically 1. So we do our switch. Now, all of a sudden, I only need 1 peanut butters, or lead. Okay, so do we need to write the little 1? No, you can. It would not be incorrect. You could still write the little 1. Now, I need 2 whole sulfates, so what am I going to wrap it in? A bracket. So I'm going to write SO4 in brackets, and the 2 will go on the outside, and then solid. How's that so far? Okay. So his name would be, it's really just joining these together. So lead 4 sulfate. Should we do one more? Is there ammonium in this one anywhere? Oh, let's look at ammonium. It's very rare, but sometimes the polyatomic ion could be actually the cation, or the metal, or acts like a metal. So it's actually not a metal, but you can have a positive or a cation that's polyatomic. So if you look up ammonium, it is not, you're not going to find it on your periodic table in the elements. In the polyatomic, what's ammonium? NH4 plus. Okay, and what is nitrate? Now again, it doesn't end in "ide", so that's your hint. I need to look in my polyatomic. Nitrate, Aaron? Yeah, what's nitrate? NO3 negative. So nitrate is NO3 negative. Yeah. Okay, so in this case, how many do we need of each? We have 1 and 1 charge. We switch it, how many do we need of each? Just 1, right? Just 1 of each. We switch 1 down here, 1 down here. Now, If we needed more than one ammonium, we'd have to put it in brackets. If we needed more than one nitrate, we'd have to put it in brackets. So in this case, we only need one of each, so we're just going to write them beside each other, like that. And that's ammonium nitrate. So there is a case, I'm going to write an example down below. You might come across, did everyone get that down? Give you a second. You may come across one day an ammonium, let's say ammonium bonded with sulfite. Ammonium and sulfite. And sulfite. Okay, so ammonium is NH4 positive, and sulfite is SO3 negative. So when we do our switch, I need how many ammoniums? 2 ammoniums. So in that case, I would actually have to put my ammonium in brackets to write the 2 there. And we only need 1 sulfite, so I don't need brackets around that guy. So that's a rare case. It's usually the brackets are behind the anion. The most polyatomics are negative charges, but you can have that situation with ammonium. And so his name would be ammonium sulfite. Oops. So at this time, I'm going to get you to work through the next 2 pages. So these are polyatomic ions. And we are almost done. At the end of this, we're basically done naming ionic compounds. And we get to start molecular. So we want to make sure we get good at ionic. Maybe we'll have a little quiz on naming ionic compounds tomorrow or the next day. And when I say little, and not as like a lot smaller than yesterday's. So literally half of the front of a page. Just here's a chart, name these, maybe it has the symbol, and you name the name, or maybe it has the name, you give the symbol. Really short and sweet, okay? So I'll give you some time now if you can work through the next 2 pages in your workbook. Okay, so let's just go through these. So there are solutions for this front sheet. We did the first few, right? So you had to start at, whoa, wait, we have a delay here. Magnesium. And so one of the hints I told you is put like the charge, this 3 represents there's 3 oxygen atoms and 1 carbon atom bonded together. And as a group, this group together wants to gain 2 electrons. Okay, the group of them. And manganese wants to lose 2, so we actually only need 1 of each. So we don't need brackets, and that's manganese carbonate. So if we have gold is Au3 positive, and sulfite is SO3 minus, gold wants to gain 2, and sulfate as a group needs to gain, or wants to lose, sorry, gold wanted to gain 3, sulfite wants to lose 2, so we need 3 full sulfites, and that's when you need those brackets. Okay, so the rest of them, we have zinc hydrocarbonate became Zn. You need brackets around your hydrocarbonate, HCO3 with a 2. And again, make sure you have solid on all of these. If you forgot your state, write that in, because you'd lose marks on that. Ammonium nitrate becomes NH4NO3 solid. Copper, you need copper 1. Phosphate becomes, you don't need brackets because you only need 1 phosphate. Our silver hydroxide, we only need 1 of each, so again, no brackets. Now, aluminum hydroxide, aluminum is A3 positive, and so we need 3 full hydroxides, right? All of hydroxides have a 1 minus, and we need 3 of those, and so that's where brackets needed. Then we have our lead 2 phosphate becomes Pb3, and the PO4 has to be in brackets with a 2 outside. Again, solid. Acetate is a really funny looking compound. And it's basically written how it's bonded together. That's why the oxygens are not really put together in the carbons. Literally, if you were to draw it, it's written how it's bonded. Okay, and that's why it's CH3COO. So there only need one of each. Correct? Yes? Yes. So you probably wrote it like this, right? Potassium acetate. The last one, manganese 5. Yes, 5 is not on the periodic table. It has more than two common ionic charges. So they only have room on the periodic table for those two. So we have 5 plus, this is a 2 minus, so again, these switch. We need brackets because you need more than one sulfates. All right? So on the next page, I think most of you are working on that or are almost finished. I'd like you to try and do this page for homework or get this done. Is that too much? Is that manageable? Yeah? So this part's a lot easier. Oh, no, it's still a lot of work because we're still making the compound. So they just give us the name. So we have ammonium, which is NH4 positive. Carbonate is what is carbonate? C2O7? No, that's dichromate. Carbonate, CO3 2 minus. So here's an example where I need 2 ammoniums and 1 carbonate. And don't forget your solid. So ammonium as a group had a 1 positive charge.
Mr. Meserden, Block 2, Biology class, please proceed to the atrium to check out the NATE program. Also, could all teachers please follow